Hello grade 6s. Today what I'm going to do is I'm going to introduce you to factor trees and prime factoring. And I find it's something that's going to come up in grade 6 and grade 7 and grade 8 and into your future. So it's a really good thing just to take some time here just to look at it and make sure that we understand. So we've been looking at in the previous lesson on what is a prime factor. And prime factors are numbers that only factors they have is 1 in themselves. So for example, 4 is not a prime factor because if you did its factor tree, you would have 1 and 4 and 2. So there's more than 2 factors for it, so 4 is not a prime factor. But something like 3 would be a prime factor because its only factors are 1 and 3. So 1 and itself, if that's the only factors it has, it's considered a prime factor. So just to give you a heads up on what prime factors are, for example, 2 is a prime factor, 3 is a prime factor, 4 isn't, 5 is, 6 is not, 7 is, 8 is not, 9 is not, 11 is, 13, and you could keep working your way up to figure out which other ones are. So this is what we want to do. We want to take a number, like in this case, we want to take the number of 36, and we want to figure out what are the prime factors that make up 36. So we're going to use something we call a factor tree. So a factor tree kind of looks like this. You start with a 36 and you ask yourself, hey, what prime factor, 2, 3, 5, 7, 11, 13, goes into 36? So what number is a factor of 36? Well, here's a really simple rule for you. If the number is even, so that means it ends with a 0, 2, 4, 6, 8, it is divisible by 2, which is a prime factor. So what we do is in our factor tree, we split it into 2. So we put 2 on one side, and then you think to yourself, 2 times what gives me 36? Or you can think of it as this way. 36 divided by 2 gives me what? And the answer to that is 18. Now 2 is a prime, so I usually circle it. 18 is not a prime, so therefore I split it up into 2 more. Now I ask myself, okay, 18 is even, so I know 2 is a factor. And what's half of 18? And you could probably guess the answer to this is 9. So 2 again is a prime, so I circle it. Now 9, is it prime? And the answer is no. So we got to break it up into another tree. So here we have 9. 9 is not even, so we can't divide this by 2. But I'm hoping you say, oh yeah, 3 times 3 gives me 9. 3 is a prime, so I circle it. 3 is a prime, so I circle it. So this is what I want you to notice. The prime factors of 36 are 2, so that's where I got the first one, another 2, a 3, and another 3. So you can see the prime factors of 36 are 2 times 2 times 3 times 3. And if you punch this into your calculator, 2 times 2 times 3 times 3, that should equal 36. And if it does, you know you got it right. Let's just try one more quick one here. Let's say I asked you for the prime factors of, let's go 42. First thing you say to yourself, oh, I know this one. It's even, so it's going to be 2. Oh, what's half of 42? Half of 40 is 20. Half of 2 is what? Oh, I think it's 21. Now you ask yourself, is 2 is prime, but is 21 prime? And I'm hoping with a little thought you say, no, it's actually not prime. 21 can be divided by 3. Now here's a little trick. 21 has the digits of 2 and 1 in it. So 2 plus 1 is 3. So if you add up the digits and it adds up to a number that you can divide by 3, clearly you can divide 3 by 3. It actually is divisible by 3. So 3 times what gives me 21? The answer is 7. 3 is prime, 7 is prime. The prime factors of 42 are 2 times 3 times 7. So I hope this has helped you kind of start understanding the world of prime factor trees. Have a good one, grade 6.